So if events are not independent, that brings us to, well, then they must be dependent. So dependent events is when the occurrence of one event does have an effect on the other event, which then also brings us to conditional probability. Conditional probability is the probability that an event occurs given that another event has already occurred. So now we're talking about dependent events where something's going to happen and it's actually going to change the chances that whatever happens after it is going to occur. Using our symbols, the probability of A and B is going to be equal to the probability of A happening times the probability of B happening given, do you see that vertical bar there? That means given that event A has already happened. So let's take a look at example 4, finding the probability of dependent events. A bag contains 20 $1 bills and 5 $100 bills. You randomly draw a bag or a bill from the bag, set it aside, and then randomly draw another bill from the bag. Find the probability that the first bill is $100 and the second bill is $100. So, if I want the probability that the first bill is $100, in my bag, I have 25 total bills. Of those 25, 5 are $100 bills. So that gives me the probability of 5 out of 25 to get a $100 bill. Now, it specifically says that we're going to set it aside. So picture taking it, setting it next to you on the table. It's no longer in the bag. So now they want to know, okay, well, you're going to reach in again and you're going to draw another bill. Well, what's the probability that this one is also $100? Well, I already took $100 out of the bag, so it's not there anymore, which means there are only 4 $100 bills left in the bag. And because I already took one out, there's no longer 25, there's 24 total. So the probability here is going to be found by taking 5/25 times 4/25. If we simplify 5/25, that's going to give us 1/5, times, if we simplify 4/24, 1/6. 1/5 times 1/6 is 1/30th, which is roughly 0.033, which is roughly, you have a 3.3% chance of pulling $200 bills out of the bag. Part B, what's the probability that both bills are $1? Well, you reach into the bag, what's the probability that you get a $1 bill? There are 20 of them out of 25. So 20 out of 25 times. You take the $1 bill, you put it in your pocket, which means in the bag, when I reach back in, there are now only 19 left. I have one of the bills in my pocket, so now there's only 24 left in the bag. If I simplify 20 out of 25, I get 4/5 times 19 24ths. That's going to give me 76 out of 120, which is the same as 19 out of 30. If we convert that into a decimal, that's roughly 0.6333, which is roughly 63.3%.